Hello, grade 9 students. How are you there? Are you ready for the final test? I want you to pass. That's why I care about you by making this video so you can repeatedly watch this according to your language that you can set here on YouTube. And so here it is. Let me show you.
In progress.
Now, our lesson for this week is this. For you, Science Matayom 3 students, you know, we're ending this lesson, the last chapter on Sun, Earth, Moon, System, and Space Technology. But specifically for this week, it's topic 8.2 phenomena due to the axial tilt and Moon's revolution. Okay, so what is this all about? What is this all about? This phenomena due to the axial tilt. Our Earth is spherical. That is round like a ball. Maybe like my head, right? It rotates on an imaginary axis that passes through the North Pole, the center of the Earth, and the South Pole. Now, this axis is tilted at an angle of 23 and 1/3 degrees. This tilt is known as the axial tilt. Oh, what is it? The axis is tilted in the same direction throughout a year while the Earth revolves around the sun. Okay? Now look at this picture of this Earth. This is the northern hemisphere. This is the rotation of the Earth. And this part is the southern hemisphere. Look at that. This is the axis being tilted. All right. And now is this is the 23.5 degrees tilting of the Earth from its axis. Okay? And now this is the equator where the sun actually is at its highest peak. And so look at this axial tilt. This axial tilt, tilt, look at my finger. Okay, look at that one. This way, okay, causes a few phenomena such as the occurrence of seasons and the different lengths of daytime and nighttime. Now let us understand seasons. Some countries like Japan and Korea have four distinct seasons: spring, four of them, summer, and what are the two? Autumn and winter. Do you have that in Thailand? Since I am now in Thailand and I'm trying to make you understand what this means, we do not experience seasons in Thailand as we are very near to the equator or near the equator, I should say. Seasons are caused by the combination effects of the axial tilt, or this way, and the Earth's revolution around the sun. The axial tilt causes some parts of the Earth to receive more sunlight than others. Those parts that are tilted towards the sun receive more sunlight. I will explain to you what it means. Look at the sun and the earth during December and to February is winter time in northern hemisphere, meaning in North America, all right? Or even in Europe, okay? Those countries which are in the northern hemisphere, while it is summer in the southern hemisphere in Australia and even there in Antarctica, right? Okay? So I want you to see this during March to May is spring in northern hemisphere and autumn in southern hemisphere. Okay? And so during June through August, it's summer in northern hemisphere, while it is what? Winter in the southern hemisphere. What about during September through November is autumn in northern hemisphere while it's what? Spring in the southern hemisphere. Do you understand now? Right? Why it's like this? Okay. Now, let us explain further. When the northern hemisphere is tilted away from the sun, this one, away from the sun, this way, it will experience winter, and the southern hemisphere, which is tilted towards the sun, will experience summer. Why is that? Well, very easy to explain because this southern part is closer to the sun. That's why it's summertime. And this northern hemisphere is tilting away from the sun. That is why it's colder. It's winter time. You see that? Only 23 degrees. Look at that one. 6 months later, look at in here, when the northern hemisphere is tilted towards the sun, this way here, it will experience summertime. That is why during June to August, it's summertime because it's closer to the sun. It's tilted to the sun. I mean, it is tilted, that kind of inclination. It will experience summer, and the southern hemisphere will experience winter time because it's far from the sun. Do you understand now? Interesting, right? The seasons in the northern hemisphere are opposites to those in the southern hemisphere. Okay? When the southern hemisphere is tilted toward the sun, here, southern hemisphere toward the sun during, summertime. Where is summertime? Okay? Here, the northern hemisphere is tilted away from the sun. Let me repeat. When the southern hemisphere, okay, this one is tilted towards the sun, it's summertime. The northern hemisphere is tilted away from the sun, therefore it is winter time. It's cold time, all right? Now look at the pictures of these trees as they change their colors of the leaves and the number of leaves. So, with each different season, the color of the surroundings changes too. All right? The sports we play and the clothes we wear are affected by the seasons. Look at the color. All right? So, here, during cold winter, we build snowmen and wear thick clothes, but in summer, we play at the beaches and wear thinner clothes. Okay? The animals are also affected by the seasons. Some migrate to warmer places or hibernate during winter. I am just thankful. And we are thankful. You should be thankful. We are in Thailand. We don't experience extreme heat nor extreme cold like winter, because we have here the wonderful temperature and season throughout the year. We don't need to understand this part, but what are the different lengths of daytime and nighttime? Do you know them? Now, we have day and night. Why? Because our earth rotates, rotates. Okay? At any one time, only half of it faces the sun. This part of the earth experiences daytime. The other side of the earth does not receive light. It is in darkness and experiences nighttime. Let's explain further. Look at here. This is the sunlight, and so we are here. If the sun is here, our part right here is midnight time. And we go to the other side. When we are right here close to the equator, this is dawn, before the breaking of the day when we sleep, and just before we wake up in the morning at around maybe 6 o'clock, you know. And then during noontime, the sun is here. It's hot, okay? And then during midnight, not midnight yet, during, the closing of the sun, the sunset is dusk, when the sun, the daytime and the nighttime are really competing against each other. It's dusk time. You see how it changes from day to night on a particular place on earth happens, all right? Look, the earth takes how many hours? 24 hours or a day to make a complete rotation on the axis. Remember the axis? However, due to the axial tilt, not every place has 12 hours of daytime and 12 hours of nighttime. Do you understand that? So during summers, the daytime is longer than its nighttime. Have you noticed? The sun rises higher during noontime. Yes. And what about during winters? So during winters, the daytime is shorter than its nighttime. The sun rises lower during noontime. Let me show you. Remember, this is the axis because the earth is tilting to this axis here, and this is the equator. All right. So this is the sun shining to the earth during summer in northern hemisphere and winter in the southern hemisphere. Okay. Remember, I told you why it's summer here. Yeah, and why it's winter here is because this is closer to the sun and this is farther from the sun. Remember that. And so, look at this path of the sun during summers and winters. Since it's shorter, okay, east to west, the sun always shines from east to west during winter time. The path of the sun is shorter. During summertime, the path of the sun is longer. All right? Do you understand that? So, there are 2 points throughout the year when the axial tilt reaches its maximum tilt towards the sun. This usually happens around 21st of June and 21st of December. Okay? Now, what do you call these days? These days are known as solstice or solstices, plural. Okay? All right. So first, remember the date, 21st of June and 21st of December. Okay? Are the solstices. Around 21st of June, it is summer solstice in the northern hemisphere. It's hot time, which marks the beginning of summer. Remember? June 21st is the beginning of summer. And in the southern hemisphere, it is winter solstice or solstice, which marks the beginning of winter. When is that again? It is in or on the 21st of December. Now, summer and winter solstices are the longest day and the shortest day, respectively, for each hemisphere. In other words, during 21st of June, that is the longest day. And during the 21st of December, that is the shortest day. Do you understand? Right. Now let's look at the relationship between the sun and the earth during the 21st of December, which is the winter solstice in the northern hemisphere. And at the same time, it is the summer solstice in southern hemisphere. As we go to the 20th of March, we see here a vernal equinox in northern hemisphere or autumnal equinox in southern hemisphere. What about during the 21st of June? We see summer solstice in northern hemisphere and or while it is winter solstice in southern hemisphere. What about during the 22nd of September? Oh, it is autumnal equinox in northern hemisphere or the vernal equinox of southern hemisphere, right? Now, it goes back again to the 21st of December. So, 6 months later, around 21st of December, in the northern hemisphere, winter begins. It is winter solstice for the northern hemisphere and summer solstice for the southern hemisphere. As the Earth moves around the Sun, it reaches 2 points where the Sun is positioned exactly above the equator. So this usually happens around 20th or the 20th or on the 20th March and on the 22nd of September. Okay? All right, this one. So these days are known as equinox. All right. And on these 2 days, that is 20th of March and 22nd of September, both the hemispheres, that is the northern and the southern, get the equal length of day and night. Remember? Right? Equal length of day and night. While in this area, they are not equal. All right? We have the shortest and the longest. Around the 20th of March, it is vernal equinox. And in the northern hemisphere. And autumnal equinox in the southern hemisphere. All right? Around the 22nd of September, it is autumnal equinox in the northern hemisphere and vernal equinox in the southern hemisphere. They mark the beginning of the spring and autumn. Okay? However, for people staying near the equator, where do you stay? Is your country in Thailand? Do you think you're close to the equator? They neither or neither experience any seasons nor different lengths of daytime and nighttime. Why? Because we are not in the extreme northern nor in the extreme southern hemispheres. All right? Do you understand? We are closer to the equator, closer to the, where the sun revolves. I should say the sun is not revolving. We, the earth, are revolving around the sun. Okay? We have these amazing facts. What are they? One, in polar regions such as Finland, Greenland, look at my look at the aurora lights there behind me. That is in Finland and there in the northern hemisphere in the polar regions. This Greenland and Alaska, the sun remains visible in the sky for 24 hours around summer solstice. In other words, you don't know, oi, even if it is midnight, the sun is still up. This phenomenon is known as the midnight sun. They also experience polar night. What is polar night? When the night lasts for 24 hours. It's like, oh, when is the day coming? It's whole night time. All right? 24 hours. This occurs around winter solstice. All right? Now, hot tips for us to remember. The word equinox comes from Latin, which means equality of day and night. Wonderful. What about the phenomena due to the moon's revolution? The revolution of the moon around the earth causes the phenomena of moon phases, the tides, and different times of moonrise and moonset. Look at this. Okay, do you see now the shape of the moon when it is lit by the sun? This is called here an example of moon phase. So let us learn the moon phases. The moon does not produce its own light. We knew that already in our study before, right? It is visible from the Earth. Why? Because it reflects light from the sun right in this area. So, however, it seems to have many shapes when we observe it every day. How does it happen? This is because we see different areas of the moon's surface lit up when it orbits around the Earth. All right? These changing shapes are known as the phases of the moon. All right, now you know. I want you to see this picture. Right here is the sun. This is the earth, and this is the moon revolving around the earth. When the moon is between the sun and us here on the earth, the side of the moon that is facing us, this side, is in darkness and we don't see the moon during daytime, right? Look at that. Okay? And we call this again, we cannot see the moon at this phase. It is known as new moon. All right? And then slowly, as the moon continues to rotate, the area of the lit surface that we can see from the earth gets bigger. This one. So this one gets bigger. This one is the one we see it from here. This is what we see. Okay? From our eyes, this is what we see. It becomes bigger from nothing to something smaller, but it's becoming bigger. It's called the new crescent moon. All right? Okay? New crescent moon or new moon, new crescent moon, because this is how it's shaped, like crescent moon. And later we see the moon as the full circle right here. Before we go into that, let us explain here first. When the moon is around here and we are standing here, we see the new half moon. Okay, new half moon. But when the moon again revolves around the sun in this area, this is what we see being lit by the sun. It's almost full moon. It's called new gibbous moon. All right? Okay? So in between are the new crescent moon, new half moon, and the new gibbous moon in between new moon and full moon. But during the full moon, we see this really full, being lit by the sun. As the moon rotates, the area of the lit surface, what we can see from the earth, gets smaller again. From the earth, okay, gets smaller until we see no moon. That is the new moon. So it gets smaller and here, old gibbous moon, it becomes smaller again to the old half moon, to the old crescent moon until we don't see it again because it's new moon. All right? In between old gibbous moon and old half moon and old crescent moon. This whole cycle takes 29.5 days and will repeat itself. All right? In one complete cycle, the moon revolves or moves around the earth once, and then we call it 1 month. All right? We actually like, you know, uh calculated into 30 days. Okay, we round it off the 29.5 into 30 days. The phases of moon helped us to derive the lunar calendar or the moon calendar in the olden days, used by the Jewish people, the Hebrew people in the Bible. It was also used in the determination of the dates of religious activities and in astrology. Now, let us watch this moon phases demonstration video, all right? Wow. Moon phases activity for next time you see the moon by
Hi, my
Emily.
name is Emily Morgan, and I'm the author of Next Time You See the Moon from NSTA Kids. And I'd like to share a simple activity with you that can help you understand why the moon looks different at different times throughout the month. Why sometimes it looks like a banana, and other times it looks like half of a circle, and other times it looks like a big
Wait, she has a better accent than me, an American accent. I'm trying my accent to make it like Tinglish, or Filipino English, so you and I can understand. All right? Because if I copy her accent, you may not be able to understand me well. But let us get on well with how she speaks.
round ball. Well, to do this activity, you only need four simple things. You need a lamp with the shade removed,
Hmm.
a white foam ball, a
Right.
pencil, and a dark room. The
Okay.
darker the room, the better. Now, in this
Yes.
model, the lamp is going to represent the sun, and of course, the white foam ball is going to represent the moon, and your head is going to represent the earth.
Oh,
So let me
yeah.
show you how this works.
Especially my head.
We know that the moon
Ooh.
orbits the earth. So in this
Ooh.
model, I'm going to get the moon, the foam ball, to orbit the earth, my
All
head.
right. Look at that.
Notice that no matter where the moon is in its orbit, half of it is always lit up by the sun.
Yeah. You don't see
But
it.
when the moon is in this position, I can't see any of the lighted side of the moon from Earth,
Right. That's it.
my head.
Correct.
From this
So,
angle, you can see what I am seeing from Earth. We call this new moon. When
yeah.
it's new moon, we look up at the sky and we can't see the moon.
I
It's
told you.
there, but the side that's reflecting sunlight is away from us.
Right.
Now, as I slowly make the moon orbit to my left, I can begin to see a tiny sliver of that
Crescent
lighted
moon.
side. We call that a crescent moon.
A crescent
As the
moon.
moon keeps orbiting, we can see more and more of that lighted side. We see half of the lighted half, which is a quarter moon. In this case, a first quarter moon.
Yes.
As we keep orbiting, we see almost the whole lighted side. We call that a gibbous moon.
Yes. Give us
Then, when we can
moon.
see the entire lighted half of the moon, that's a full moon. As the moon continues in its orbit, we begin to see less and less of that lighted side. We're back to a gibbous moon, but this time the light is on the opposite side.
Okay. You see that?
Then another quarter moon, last quarter moon to be exact.
This one here. Look at that. Yes.
Another crescent,
Crescent moon.
and finally back to new moon.
Yeah, new
And the
moon.
cycle begins again.
Wonderful, beautiful, isn't it? The phases of the moon. All right. Now that you have seen it, what else do you think?
So why does the moon appear in different shapes throughout the month?
Oh.
Because of its orbit.
Yes.
The shape or phase of the moon depends on where it is in its orbit around Earth.
Orbit or its
It
revolution.
takes about a month for the moon to orbit the Earth. So when you look up at the
How
moon
long?
today, know that you'll see that same phase again about a month from now.
Yes.
Thank you for watching, and I hope you give this
Thank you,
activity
Emily.
a try. And I
Right.
hope that you have a sense of wonder next time you see the moon.
Oh, yes. Of course.
For a
Look
full
at that.
description of this activity and other resources for teaching about moon phases, go to www.nsta.org/nexttime-moon. There are moon
Thank
calendars
you.
and other science and reading activities there. For more information about the Next Time You See book series, visit www.nexttimeyouSee.com.
Thank you, Emily, for educating us about the moon. And now let's move on to the next topic because we still have a lot to study. What about tides? Do you know tides? Okay. I live near here, banks and beach. I love water. Ho ho. And then before I go to the beach, I have to look at the schedule. When is the high tide and low tide so I can swim during high tide? So what are tides? Tides are the alternate rising and falling of the ocean in a day. They are caused by the gravitational force of the moon. This force attracts the ocean to bulge out towards the moon. Another bulge occurs at the opposite side. This creates high tides at the bulges. Look at this figure about the occurrence of the tides. They are marked here, high tides, and this is high tide also. All right. Look at that A, B, C, D. So we have the moon here. Okay. Why do you think is high tide here? This part. Look at it, it's not so clear, right? Can you see that? The high tide, the drawing here. Later on, this is a better one. A and C experience high tides. B and D experience low tides. As the earth rotates, rotates, this one rotates faster than the moon revolution, every place on the earth, just like in Thailand, experiences two high tides and two low tides each day. So the ocean is constantly moving from high tide to low tide and then back to high tide again. All right. So we have some amazing facts that I want you to know. The word month comes from an old English word, means moon. In the early times, a month in a calendar was the length of time between the new moons. This is known as a lunar calendar or moon calendar because lunar means moon. Now, the Islamic and Chinese calendars are still based on the movement of the moon. When it is new moon or full moon, the gravitational forces of the moon and the sun are combined. The high tides are very high and the low tides are very low. Can you imagine that? These are known as spring tides. Why? They occur when the earth, moon, and sun are in a line. Okay, remember? Spring tides. This is the figure of spring tide during the new moon. Is very high tide during this time. And see, when the moon is even right here, it is also spring tide during the full time. Again, the moon is in between the sun and the earth. This is springtime during new moon. Well, when the moon is there or the earth is in between the moon and the sun, it is springtime during full moon because you see this is full moon. When it is new half moon, or old half moon, the effects of the gravitational forces of the sun and moon cancel each other. This results in a smaller difference in the high tide and low tide. And what is this known? This is known as neap tides. Look at the neap tides. You see that? It's not very low. And here it's not very high either. Okay, why? Because the moon is right here. There is a gravitational force between the earth and the moon. In other words, the tide is pulled up. The water is pulled right here by the moon, both of their gravity. So, tides are important as they create tidal streams that circulate the ocean, bringing fresh food and water to other areas. Tidal streams, be careful with the tidal streams. Tides also create a great ecology at the beaches as different living things adapt to the high tides and low tides daily. Knowledge of tides is important for navigation of ships through coastal waterways. The ships, I'm not talking about the sheep, the animal, but I'm talking about ships, they like the vessel in the ocean through coastal waterways, fishing, and also a variety of water related sport activities. I want you to visit my place here in Bangsan, and you'll see a lot of water related sport activities and banana boats and all those other wonderful things. I want you to watch this video about the tides.
You know, if Shakespeare had been an astronomer, he'd have said that there is a tide in the affairs of the universe, and on such a full sea are we now afloat. He would have been right. You might just think of tides as the ocean going in and out every day, but in fact, what astronomers call tides are a subtle but inexorable force that have literally shaped most objects in the universe. And to understand tides, we start with gravity.
One giant leap for mankind.
Gravity is a force, and it weakens with distance. An important thing to note is that we measure gravity from the center of mass of an object, not its surface. One way to think of the center of mass of an object is the average position in an object of all its mass. For an evenly distributed sphere, that's its center. Right now, unless you're an astronaut, you're about 6,400 kilometers from the center of the Earth. If you stand up, your head is a couple of meters farther away from the Earth's center than your feet. Since gravity weakens with distance, the force of Earth's gravity on your head is an eensy-weensy bit less than it is on your feet. How much less? A mere 0.00005%. And that's way too small for you ever to notice.
Yes.
But what if you were taller? Well, the taller you are, the farther your head is from the Earth's center and the weaker force it will feel. If you were, say, about 300 kilometers tall, the force of gravity would drop by about 10% at your head. That probably would be enough to notice if you weren't dying from asphyxiation and, being 300 kilometers tall. This change in the force of gravity over distance is what astronomers call the tidal force. When you have a massive object affecting another object with its gravity, its tidal force depends on several factors. For one thing, it depends on how strong the gravity is from the first object. The stronger the force of gravity, the stronger the tidal force will be on the affected object. It also depends on how wide the affected object is. The wider it is, the more the force of gravity from the first object changes across it, and the bigger the tidal force. Finally, it depends on how far the affected object is from the first object. The farther away the affected object is, the lower the tidal force will be. Tides depend on gravity, and if gravity is weaker, so is the tidal force. The overall effect of the tidal force is to stretch an object. You're applying a stronger force on one end than you are on the other, so you're pulling harder on one end. That'll stretch it. And this is where tidal forces become very important. Look at the moon. It has gravity, but much less than the Earth because it's less massive. It's 380,000 kilometers away, so the gravitational force it has on you is pretty small.
Yes.
And you're pretty small compared to that distance, just a couple of meters long from head to feet. But the Earth is big. It's nearly 13,000 kilometers across. That means the side of the Earth facing the moon is about 13,000 kilometers closer to the moon than the other side of the Earth. This is a pretty big distance, enough for tides to become important. The side of the Earth facing the moon is pulled harder by the moon than the other side of the Earth.
Yes.
So the Earth stretches. It becomes ever so slightly football-shaped, like a sphere with two bulges, one pointing toward the moon and one pointing away. This is probably the weirdest thing about tidal forces. You might expect only one bulge on the side of the Earth facing the moon. But remember, we measure gravity from the centers of objects. The side of the Earth facing the moon feels a stronger pull toward the moon than the Earth's center, so it's pulled away from the center. But the side facing away from the moon feels a weaker force toward the moon than the Earth's center. This means the center of the Earth is being pulled away from the far side. This is exactly the same as if the far side is being pulled away from the center. And that's why you get two bulges on opposite sides of the Earth. The tidal force is therefore strongest on the sides of the Earth facing toward and away from the moon, and weakest halfway in between them on each side. A lot of the Earth is covered in water, and water responds to this changing force, this stretching. The water bulges up where the tidal force is strongest on opposite sides of the Earth. If there's a beach on one of those spots, the water will cover it, and we say it's high tide. If a beach is where the tidal force is low, the water's been pulled away from it, and it's low tide. But wait a second. The Earth is spinning. If you're on a part of the Earth facing the moon, you're at high tide. 6 hours later, a quarter of a day, the Earth's rotation has swept you around to the spot where it's low tide. 6 hours after that, you're at high tide again, and then another 6 hours later, you're at low tide for the second time that day. Finally, a day after you started, you're back at high tide once more. And that's why we have 2 high tides and 2 low tides every day. Very generally speaking, the ocean tide causes the sea level to rise and fall by a meter or 2 every day. Incidentally, the solid Earth can bulge as well. It's not as fluid as water, but it can move. The tidal force stretches the solid Earth by about 30 centimeters. If you just sit in your house all day, you move up and down by about that much, twice. Like the saying goes, a rising tide lifts all surfaces. The Earth's spin has another effect. Lag in the water flow means the water can't respond instantly to the tidal force from the moon. The Earth's spin actually sweeps the bulges forward a bit along the Earth. So picture this. The bulge nearest the moon is actually a bit ahead of the Earth-Moon line. That bulge has mass. Not a lot, but some. Since it has mass, it has gravity, and that pulls on the moon. It pulls the moon forward in its orbit a bit, like pulling on a dog's leash, accelerating it. The moon responds to this tug by going into a higher orbit. The moon is actually moving away from the Earth. The rate of recession of the moon has been measured, and it's something like a few centimeters per year, roughly the same speed your fingernails grow. Now get this. The moon has gravity. Just as the bulge is pulling the moon ahead, the moon is pulling the bulge back, slowing it down. Because of friction with the rest of the Earth, this slowing of the bulge is actually slowing the rotation of the Earth itself, making the day longer. The effect is small, but again, it's measurable. Okay, let's get a little change of perspective. Everything I've said about the moon's tidal effect on the Earth works the other way too. The moon feels tides from the Earth, and they're pretty strong because the Earth is more massive and has more gravity than the moon. Just like Earth, there are 2 tidal bulges on the moon, one facing the Earth and one facing away. Long ago, the moon was closer to the Earth and spinning rapidly. The moon's tidal bulges didn't align with the Earth, and the Earth's gravity tugged on them, slowing the moon's spin and moving it farther away. As it moved farther away, the time it took to orbit once around the Earth increased. Its orbital period got longer. Eventually, the lengthening rotation of the moon matched how long it took to go around the Earth. When that happened, the axis of the bulges pointed right at the Earth. That's why the moon only shows one face to us. It spins once per month and goes around us once per month. If it didn't spin at all over that month, we'd see the entire lunar surface. But since it does spin once per orbit, we only ever see one face. This is called tidal locking, and it's worked on nearly every big moon in the solar system. Tides from their home planet have matched their spin and orbital period. These moons all show the same face toward their planet. Now wait a second. If the moon has gravity, which causes tides, and is the root cause behind all these shenanigans, what about the sun? It's even bigger than the moon. Tides depend on the gravity from an object and your distance from it. The sun is far more massive than the moon, but much farther away. These 2 effects largely cancel each other out, and when you do the math, you find the sun's tidal force on the Earth is just about half that of the moon's. The way the sun's tidal force and the moon's tidal force interact on Earth depends on their geometry, which changes as the moon orbits us. At new moon, the Earth, moon, and sun are in a line. The moon's tidal force aligns with the sun's, reinforcing it. This means we get an extra high tide and an extra low tide on Earth. We call this the spring tide. When the moon is at first quarter, the tidal bulge from the moon is 90 degrees around from the sun's. High tide from the moon overlaps low tide from the sun. We get a slightly lower high tide and a slightly higher low tide. We call those neap tides. The pattern repeats when the moon is full. The moon, Earth, and sun fall along a line again, and we get spring tides. A week later, the moon is moved around, and we get neap tides again. Not only that, the moon orbits the Earth on an ellipse. When it's closest to us, we feel a stronger effect. If that also happens at new or full moon, we get an added kick to the spring tides. This is called the Proxygian tide and can lead to flooding in low-lying areas. Unless you live on the coast, I bet you had no idea tides were so complex. Tides are universal. They work wherever there's gravity. If 2 stars orbit each other, each raises a tide in the other. Just like the Earth and Moon, that can slow their spin and increase their separation. Many planets orbiting other stars may be tidally locked to those stars. Near a black hole, where the gravity is incredibly intense, the tides are so strong they would pull you like taffy into a long, thin string. Astronomers call this effect spaghettification. No, seriously, that's what we call it. Today you learned that tides are due to the changing force of gravity over distance. The strength of the tidal force from an object depends on the gravity of the object and the size of and distance to the second object. Tides raise two bulges in an object, creating two high tides and two low tides per day on Earth. Tides have slowed the Earth's rotation, moved the moon away from the Earth, and locked the moon's rotation in orbit so that the moon always has one side facing us. So, tide goes in, tide goes out. It turns out I can explain that. Now you can too. Crash Course is produced in association with PBS Digital Studios. This episode was written by me, Phil Plait. The script was edited by Blake DiPastino, and our consultant is Dr. Michelle Fowler. It was co-directed by Nicholas Jenkins and Nicole Sweeney, and the graphics team is Thought Cafe.
Wow! You see my handsome American brother, my boldy American brother speaks so fast, very articulate in speaking English. In case you happen to see him in this part, if you want to follow his speed, you can lower or make it slower. The speed can be slower so you can exactly follow his fast pace in his talk. Very fluent, brother. Thank you so much. Even if others think you are more handsome, and I believe my students think I am more handsome, I will give you 10 points for making me as more handsome than he is. Now, what about the different times of moonrise and moonset? Do you know? So the moon rises and sets every day like the sun. However, it does not rise in the morning and set in the evening like the sun. It is because the moon revolves around the earth, whereas the sun does not move, and it is the earth that revolves around the sun. When viewed from the Earth, the moon moves towards the east by 12 degrees every day as it revolves around the Earth. Therefore, each day the moon rises about 50 minutes later in our sky. During the new moon, the moon is between the earth and the sun. Okay? The moon rises in the morning and sets in the evening as it is at its highest in the noon time. However, we cannot see it as it is the new moon. What about during 6 p.m. or the dusk time? We see the moon right here. Okay? During the new half moon, this one here, as we are standing right here, the moon rises in the middle of the day, but we can hardly see it. All right? It sets in the what? Middle of the night. All right? It is at its highest during the sunset. All right? Okay. So, during the full moon, we see the moon rising during the sunset and setting during the sunrise. It is at its highest in the middle of the night. All right, this is the middle of the night, the highest one. And so, during the old half moon, we see the moon rising in the middle of the night. This one. It sets during the middle of the day, which is hard for us to notice it. It is at its highest during the sunrise. Okay? Now you don't need to do this workbook because you don't have it. Now let us go to the conclusions. The Earth orbits around the Sun on the axis, which is tilted how much? 23.5 degrees. Okay, we call it just, by round off 24, 24 hours. This causes different parts of the Earth to receive different amount. Wait. I'm not talking about the hours. It's just tilted. Sorry for that. It's just tilted 23.5 degrees. Sorry, I didn't mean that 24 hours a day. This causes different parts of the earth to receive different amounts of sunlight during the year, resulting in seasons and the different length of daytime and nighttime. When the earth axis is tilted towards the sun, the northern hemisphere experiences summer. Its daytime is longer. The southern hemisphere experiences winter. Its nighttime is longer. When the earth axis is tilted away from the sun, the northern hemisphere experiences winter. Its nighttime is longer. The southern hemisphere experiences summer. Its daytime is longer. The two solstices, happen on the 21st of June and on the 21st of December when the Earth's axis reaches its maximum tilt towards the sun. Hemisphere's winter solstice is the shortest day of the year, and its summer solstice is the year's longest. The moon orbits around the earth. This causes the occurrence of moon phases, tides, and the different times of moonrise and moonset. Moon phases occur when we see different areas of the moon's surface lit up when it orbits around the earth. The phases are new moon, new crescent moon, new half moon, new gibbous moon, full moon, old gibbous moon, old half moon, and old crescent moon. A spring tide has very high tides. Has very high tides and very low tides. This happens when the earth, moon, and sun are in a line. And neap tide has the least difference between its high tides and low tides. This happens when the sun and moon are at right angles to the earth. We have different times of moonrise and moonset because the moon revolves around the earth, and at the same time the earth and the moon revolve around the sun. Moon rises about 15 minutes later in our sky. I want you to turn your book to page 158 to check how much you understand this subtopic by doing test yourself 8.2. Answer all the questions, come to me, and I will give you points. And then post the points with your cell phone to our line group. All right? And then if you're ready, well, see you next time. So you will pass the test. Okay. Are you ready to answer all the questions before we move to the next topic? See you. Bye bye.